class.
सब बोर्ड नहीं दिखा.
Now it's fine.
Yes sir.
So now we are going to start with something called spin orbit coupling. You can see. Spin orbit coupling. So the way we have been studying angular momentum, तो हमारे पास जो angular momentum इधर it was एक तो हमारे पास spin angular momentum है, एक अपना angular momentum है. So both of them we had been studying. But in case of later, if you remember, जो हमारा ये है कि spin orbital coupling could be understood as a classical model. It could be understood as a classical model, and we could say, for example, an electron उसका अपना एक magnetic moment भी है, apart from its revolving around the nucleus. So एक spin orbital coupling है, एक angular momentum L. The combination of both L and S will give us the total इसका contribution, which comes in the form of J. अब हमारे पास जो ये spin orbit coupling है, it can taken जैसे electron itself is a small magnetic. So इसका जिस तरह आप कहते हैं ना, कोई भी charge sphere है, if it's rotating, it will have its own magnetic field and we can calculate it. In the same way, जो potential energy UM of a magnet, so we try to see इसका dipole moment क्या है. Just like we normally calculate dipole moment, now you are trying to calculate the dipole moment of a quantum particle or a charged particle. For example, potential energy UM of a magnetic field magnetic dipole of moment U in a magnetic field. Bn can be given as mu b cos of theta, where theta is the angle between mu and b. So the mu m है, it's mu b cos of theta. Now this mu cos theta can have two polarities. It can have values plus minus mu b. So if you remember, हमने कल कहा था something called space quantization. ठीक है, एक अगर हम स्टर्न गलरिच एक्सपेरिमेंट में इनहोमोजेनियस मैग्नेटिक फील्ड एक बीम पास कर रहे हैं, that it will take up value or down value. So it's which means space is discretely quantized. इसका मतलब है we can take both plus value as well as minus value. Or so in a spin orbit coupling, so depending upon the orientation of S, and energy of the atomic electron will be higher or lower. It will be higher or lower than mu b. हायर एंड लोअर है ना, इस तरह आपने जीमान इफेक्ट में कहा था ना कि एक मेन स्पेक्ट्रल लाइन होती है, एक स्पेक्ट्रल लाइन उसके ऊपर होती है, दैट्स प्लस एल, और एक नीचे होती है माइनस एल. सो जो उसका एक स्पेस कहाँ पर लाई करेगा, मैग्नेटिक लाइंस ऑफ फोर्सेस, हाउ, सो इट कैन हैव एनर्जी स्लाइटली ग्रेटर if it's up spectral line up होगा और lower, that's so that's mu and b. Mu So MB without its spin or coupling. अब हमारे पास ये है कि जो इलेक्ट्रॉन है, फॉर एग्जांपल we normally assign spin s को हम spin half करते हैं, which observes the double line or observe finite doubling. एक plus half है ऊपर, एक एक नीचे है minus half है, such that हमारे पास जो दूसरा 12 plus state थे, यहाँ 2s plus 1 states आएंगी. तो 2s plus 1 is 2 और s is equal to half, यहाँ से निकलेगा 2s plus 1 2, एक ऊपर स्टेट एक नीचे स्टेट है, फ्रॉम दिस half. आप इस चीज को ये तो होगी स्पिन ऑर्बिट कपलिंग. Now you can also have some other coupling which is called total angular momentum. Total angular momentum. It's of spin orbit coupling. Now you can see the total angular momentum. Total angular momentum. जो total angular momentum है, it will be now the spin of
सर स्टर्न गर्लिच एक्सपेरिमेंट अभी कहाँ हमने पढ़ा पूरा?
हाँ
सर स्टर्न गर्लिच एक्सपेरिमेंट आपने कल पढ़ाया था ना, वो तो अभी नहीं हुआ खत्म.
वो हो गया ना, इसका आइडिया जो आइडिया
सर मतलब करना नहीं है वो पूरा.
हाँ, it was okay fine. You just go and see the book of ये है ना बाइजर की बुक, and just check out and read that paragraph full, उसका एक पेज है ना. द आइडिया यही है कि मैग्नेटिक फील्ड में एक सिल्वर है कोटेड है, उसमें बीम पास कर रहे हैं. सो इन क्लासिकली जो मैग्नेटिक फील्ड है ना, इट विल रैंडमली लाई, बट सिंस क्वांटम मैकेनिक की वजह से देयर आर सम पोलराइजेशन विच आर अप, सम आर डाउन डिस्टिंक्ट. उसी को हम स्पिन हाफ एंड माइनस हाफ कहेंगे. दैट्स द क्रक्स ऑफ द एक्सपेरिमेंट. देन उसका डिटेल्स
सर मतलब कि जो मैथमेटिकल है ना, उसका मतलब कि वो नहीं हमें करना है बोर्ड पे.
हाँ हाँ, वो यू कैन सी इट, जो भी है आपका.
फॉलो मतलब
They said Stern-Gerlach experiment is not mathematically, it's an experiment which you realize in the lab. उसका experimental setup कैसे set किया Stern and Gerlach ने, to see how can prove discrete space quantization कैसे आती है. So it's an experiment rather than theoretical result. But वो experimental result किसी theoretical idea को confirm कर रहा है. The idea is that space is quantized. So Stern-Gerlach experiment अपने आप में एक experiment में है, rather it's an experimentless work. ठीक है, उसका अपना experiment का setting है, कैसे उस beam में डालते हैं वो, फिर उसमें कैसे inhomogeneous magnetic field set होता है, फिर उसमें जब in presence of magnetic field how the beam will react. Some part of the beam की जो after interacting with the magnetic field कहाँ जाएगा, the other part will have orientation in different direction, which proves the idea of space quantization. अब space quantization का basically अगर उसका theory you have to construct it, जो Schrödinger equation में हम जब निकालते हैं ना L into L plus 1, वो कहाँ से आता है, ठीक है, that comes, it's detailed जो हमने किया था exercise mathematically it's that way, but experimentally we have to show it that way. So it's an experimental result rather than a theoretical result. ठीक है
सर. और हमने ये यूनिट 3 जो आधा ही पढ़ा, हमने उसमें कुछ ही पढ़े ना, कुछ ही टॉपिक्स.
We have done all. पहले आप वो आप वो छोड़ो सिलेबस के हिसाब से, आप पहले सोचो हम क्या समझ रहे हैं, ठीक है. सिलेबस इज अ स्मॉल थिंग, गॉट माय पॉइंट. आप सोचो ये कंसेप्ट के हिसाब से rather than thinking like syllabus you have to complete. ठीक है, we'll see it later also. Got my point? Whatever is left we can just do it. So we are going to see total angular momentum. हमारे पास ये है, एक हो गया spin angular momentum. Now it's total angular momentum. तो total angular momentum में ये है this is like this. It's spin angular momentum, it's total angular momentum. Now total angular momentum में हमारे पास G as quantity. So J will be एक अपना angular momentum है L plus x spin angular momentum. So we'll have that total angular momentum जो हमारे पास होगा एक spin angular momentum होगा एक orbital angular momentum होगा जो orbit के around. So the combination of both of them will give us the total angular momentum क्या हमारे पास आएगा such that J will be equal to J into J plus 1 into H. Now यहाँ क्या कर रहे थे L into L plus 1. तो अब can say ये J as a quantity है ना it's combination of L and H. So J will be basically L plus H और L plus so S का अभी जो spin हमने वैल्यू लिया था ना एक तो either it will be plus half or it will be minus half. So plus minus 1 by half. So total angular momentum will be this orbital angular momentum plus minus this half, which is the spin angular momentum. And if L is equal to, for example, 0, J का value आएगा plus 1 by 2 or minus 1 by 2. और अगर JZ component लेंगे, it will be JZ will be अब since only इसका since L will take 0 will only take इसका magnetic moment, so it will be minus J plus 1 फिर J minus 1 so J you can see it like that. J आएगा J minus 1 आएगा J plus S आएगा both sides हम लिखते हैं यहाँ से भी वहाँ से भी so that's it. अब इसमें ये है कि if J is basically L minus S for example, तो हो गया L plus S. You can take L minus S also. So we can say J can be sometimes less than L. L or L, ठीक है क्योंकि you see जो total J है if it's plus में तो it will be always greater than J will be always greater than L. But in case of minus factor, J L minus S, so it will be always, it can be, you can see from it, L minus L. For one half coupling, this is minus, it will, J will be always then less than less. For S greater than 1 by half, J will be always greater than L. So total angular momentum can be greater or less than spin angular momentum, this orbital angular momentum, depending upon the value of S. This is from which, so and जो S है इसी को हम कहते हैं we can say it can be parallel or anti-parallel है ना जो spin है ना spin angle so इधर ये parallel होगा to the field or anti-parallel so एक direction में rotate करेगा so if it will be plus half parallel it will be 1 by 2 it will be anti-parallel it will be minus 1 by 2 or vice versa जो भी आप whatever sign you are going to take in both cases so if you want to graphically अगर आप इसको if you want to plot it here so in terms of J so अगर एक साइड से J है ये L है ये S है ना जैसे ट्रायंगल लॉ है ना L plus S will give you J so that J is equal to L plus S you can put 2 by 3 आएगा for example or if it's J is L minus S then if it will be in the opposite direction तो ये हमारे पास आएगा ऐसे L J so J will be L minus S it will be half depends for example L का वैल्यू हमारे पास यहाँ 1 plus 1 by 2 आएगा 1 by 2 it will be 1 2 by 3 1 2 3 by 2 आएगी 3 by 2 So these are two ways in which you can have. So further, क्योंकि orientation of J magnetic field है ना, एक तो ऊपर spectral line आएगी, एक नीचे spectral line आएगी. In terms of Zeeman effect, you can see it. You can see it. So then, what should we? It should give like this. It will be plus 3/2h, 1/2h. ये नीचे आएगा minus 1/2h, 3/2h, है ना, ऐसे. And they will correspond to different values. Yes, mj will be 3/2, mj will be 1/2, mj will be minus 1/2, and mj will be minus 3/2. है ना, अब देखो minus 3/2 both sides. जिस spectral line है ना, Zeeman effect में plus 1/2, 3/2, 5/2. नीचे से आएगा minus 1/2, 3/2, minus 5/2. You can see it accordingly. Minus 5/2, minus 3/2. So this is, you can, in a sense, you can see quantization here also. The total values for magnetic moment in terms of G. In terms of G. Or you can say it's space quantization of total angular momentum. Space quantization of total angular moment. Now what we are going to see, we are going to see LS coupling. Angular moment L and S will couple. जिस तरह आप कहते हैं, in your earlier classes, you just study the resultant of two forces, two or more forces, है ना? फिर आप सेम कंपोनेंट्स को ऐड करते हैं, फॉर एग्जांपल fx cos थीटा प्लस कुछ और को, एंड जो कंपोनेंट साइन में है वो अलग, we just couple them. So in the same way, there are some components of L and some components of L. The total angular momentum है L plus L S. अब इसमें L में भी है ना, x डायरेक्शन में भी हो सकता है, y डायरेक्शन में भी हो सकता है, z डायरेक्शन में भी हो सकता है. इसी तरह इसकी भी ओरिएंटेशन हो सकती है, प्लस हाफ और माइनस हाफ, प्लस 3/2 और माइनस 3/2. Some components of L and S may have components in the same orientation or direction, and some components may not. They may cancel. So you have to see how you can just see the total contribution of total L, where it's L plus L, L plus S, for example. For example, what we are going to see is it will be L is L into L plus 1 H. L that, sorry, we are going to write J जो होगा हमारे पास, it's sigma of L plus S. या L plus S. It's total. अब individually L क्या है? L के different components होंगे. L, I के components होंगे. I can be different components. In the same way, S can be different components of this S. S के भी different I components हो सकते हैं. अब देखना पड़ेगा L के कौन components, S के किन components के साथ we can add them or we can subtract them in that sense. So you can see. So we have to see which components will add or which components will cancel. For angular momentum, for example, LSG, and the Z component, and LSL and GZ in the usual ways. So for example, L होगा हमारे पास L into L plus 1 into H. LZ होगा MLH. S होगा spin component होगा ये S. S into S plus 1 into H. इस तरह SZ will be MS H. Now हमारे पास J होगा J into J plus 1. अब देखो यहाँ पर J है ना, J है यहाँ पर combination of L plus S, L plus S, L plus S. So it will be and G is that the component will be, we can say MLH H component. Both ML and L and ML are always integers or zero है ना, इस तरह वैल्यू आते हैं zero, half, 3/2, 5/2 एक साइड से, दूसरी साइड से आएगा zero, minus half, minus 3/2, minus 5. So if you start with zero, so it can be zero or greater than zero, or it can be less than zero. Depends किस पर करेगा, whether L is जो भी पीछे में कैसा L is greater than X or then it will be 2s plus, it will be J can be greater than 2s plus 1. And if L is less than S, so L can be greater than S or L can be less than S. So if it's less than S, we can have J can have 2J plus 2L plus 1 values. पिछले the exercise included previously also in there. G is equal to L plus 1 S and G is L minus S. For example, S greater than 0, J is always greater than S. L less than, for this case, J is always less than L. So in these cases, you can have these two orientations which we have. अब इसमें ये है कि सिंबल्स हैं, फॉर एग्जांपल सिंबल्स कौन से हमारे पास है, जैसे आप स्पेक्ट्रोस्कोपी में यू कैन हैव दिस सिंबॉलिकली सिंबॉलिकली क्या है, फॉर एग्जांपल हाइड्रोजन एटम है, उसका इलेक्ट्रॉन एक ही है, ठीक है, बट हीलियम एटम में दो electrons cannot be in the same possible state by Pauli's exclusion principle. एक डायरेक्शन में होगा, दूसरी डायरेक्शन में होगा. But for example हाइड्रोजन जो alkali periodic table में alkali atoms हैं जिनमें outer electron 1 है, तो उसमें एक वैल्यू होगा स्पिन का, ठीक है, only one value. जो फॉर एग्जाम्पल हीलियम एटम है, एक इलेक्ट्रॉन एक डायरेक्शन में जाएगा, दूसरा इलेक्ट्रॉन, सो शायद दे शुड कैंसिल by Pauli's exclusion principle है ना, no two states can be the same states. अगर fermions, for fermions we have symmetrization of wave functions, and for anti-fermions we have anti-symmetrization condition. On that basis we classify bosons and fermions. अब यहाँ पर ये है कि जो हमारे पास स्पेक्ट्रल लाइंस आती हैं, whether it's doublet, triplet, singlet, for example one electron will come from upper state to ground state, एक स्पेक्ट्रल लाइन निकलेगी, कभी दो निकलती हैं, तीन निकलती हैं, so depends how these J's and L's and S या J L का जो J का है in terms of L and S, which components, which lines will cancel or which lines will contribute in the total scheme of things. So we can have, for example, we can have L, you can have L2, L1. So this is 1. So L is equal to 3. In the same way, you can have L1, L, L2. So you can have the different A, B. You can have L1, L, L2. So for L is equal to 3, for L is equal to 2, for L is equal to 1. In the same way, S is equal to 1, 0. है ना? Spin orbit coupling के कितने values आएंगे? Okay, spin क्या आएंगे? 0, 1/2, 3/2, 5/2, so on and so forth. L के coupling different values आ सकते हैं अपने हिसाब से according to L into L plus 1. So the combination of both will give you, for example, different diagrams. इस तरह आप vectorially add करते हैं components, and at the end they will basically correspond to those spectral lines which we are observing in the spectra. Doublet है, triplet है, multiplet है, कितने spectral lines हम observe करेंगे, and they will basically correspond to those transition states, electrons की from state A to state B, state B to state A, ठीक है, जो you can explain it from these terms. So you can have singlets, you can have doublets, and you can have triplets. We can see the rich way by which we can have how to can spectroscopically explain lot of things vis-a-vis due to the interaction of these couplings L, L and S, spin orbit coupling and orbital momentum coupling. इन दोनों को couple करके how we can see things, how they pan out. So I think we'll stop to